Hello, my name is IvoCapelo, and today we are going to look at my contribution for the Wizardry VR project for the VR module of Teesside University. In the ideal version of this project, users would begin in an old castle hallway, standing in front of an old door. A voice or a UI prompt would beckon them to knock on the door, upon which it would open and reveal a room with several tables and a professor. The professor or a UI prompt would tell the user to move about the room between tables. At each table, a wand and a new spell would be learned. These would include levitation, pushing, disintegration, and fireball. Upon learning the spell, the user would grab the wand and do a circular motion to activate it, and could then flick it at a training dummy to cast the spell. By rotating his other hand, the user would open up a menu that would allow for spell selection, and they would then be free to play in this toy box environment. My contribution focused mostly on the player interactions with the world. This means teleportation, moving around, wands, interacting with them, and a system for retrieving them. Casting spells by doing gesture recognition. This was where most of my time was spent. Choosing spells by showing a menu. The main door that would open upon knocking. But also work as a producer and how I went about mobilizing my team during the semester. Let's start with teleportation. In the scenario, the player would need to move between each table to learn a spell. I started my work based on the template, BP Motion Pawn and BP Motion Controller, that allowed for free teleportation within Unreal's nav mesh. But what we wanted was actually static teleportation points instead of free roaming. This is because, given our simple scenario, we can always make sure that the player only needs to face forward, reducing the probability that they will tangle up their cables. For this, I implemented a reusable blueprint called Movement Place that would be an invisible plaque next to each table to where the player would move to. Let's start by dissecting the movement place. Looking at the graph scene, we can see three elements: the giant collider to allow for easy detection, an arrow that indicates the direction the user will face to allow easy configuration of where teleportation orientation will be, and the square that would be invisible in the final version that represents the floor placement of the teleportation pad. In terms of code, it barely has anything, only functions to enable or disable the collider. The true teleportation behavior is actually in the pawn and the controller. The pawn starts by instantiating two motion controllers on startup, the left and the right. One of them is merely an inverted scale of the other. It then waits for input separately for each one. When the corresponding input is pressed, it marks the correct controller as active for teleportation and deactivates the other one. When released, it calls the execute teleportation function on itself. In this function, it checks whether conditions for teleportation have been met, prepares a camera fade, teleports the player using the destination provided by the motion controller, and then fades back in, resetting all necessary values, finishing the teleportation cycle. The motion controller, in terms of scene graph, has a teleportation cylinder with an arrow that is used to show where the player is teleporting to and will always be drawn on top of the geometry. Code-wise, in the motion controller, four functions were created: activate and disable teleporter, show and hide the teleportation cylinder. Trace teleport destination uses the direction and positioning of the controller to trace for any movement places collider. If found, it verifies if it is in a place that can be teleported to within the nav mesh, and chooses that movement place as a teleportation goal. Finally, get teleport destination returns the information necessary to place the player with the correct floor height within teleportation goal. Every frame, if the teleporter is active, the controller attempts to trace for a destination. If found, it attempts to place teleport cylinder in a valid position and prepares all information required for teleportation. It causes a rumble to happen and awaits for the pawn to handle the actual teleport. In terms of design, movement places can be placed near each table with the arrow used to indicate where the user will be facing. This would allow users to interact with the demo without rotating excessively and getting their wires tangled. Additionally, playtests show that it was easier to keep an already selected movement place highlighted until another is selected, rather than disabling it every time it loses trace. The player can now move around fixed points we control in our scenario, and teleportation is finished. Moving on to the wand. For the wand, once again, I reused some of the template objects already existing. A BP pickup cube that had grabbable properties was altered in order to create the pickup wand. The wand spawner was created, and the BP motion controller was tweaked. The pickup wand simply has a new mesh and uses the code that BP pickup cube already had, with little changed. Looking at the wand spawner, this blueprint solves the issue of losing wands. Since the player cannot freely roam, if they threw a wand out of range, how could they pick it up? The wand spawner ensures that only a single wand instance exists at any time, and that the player can retrieve it wherever a wand spawner exists. The first time the player tries to grab a wand, it instantiates a new wand, sets it as a global variable, and simulates the player picking up that wand. Any successive pickup will use the wand in the global variable instead of creating a new one. The motion controller handles the hand avatar of the player and positions the wand inside itself. New models and animations of the hand require me to re-implement the interpolation states of the hand avatar from open to overlapping and grabbing. The code remained mostly the same, with the difference that I added a specific wand position that allows me to control the position and orientation of the wand once grabbed. When integrating spells, this code would also ensure that letting go of the wand would deactivate it and stop any ongoing spells. The player can now pick up a reusable wand with visual feedback of the action and throw it around. Optionally, we were considering adding new hand states for teleporting, where the hand would simply point forward, and have a hand state for opening the menu, but the open hand works just fine for that case. For casting spells, I wanted to make full use of the potential of virtual reality, and instead of pressing buttons, wanted to use as much physical interaction as possible. What this meant was that I wanted to translate gestures into input. A circular motion would activate the wand, upon which sparkles would be emitted, and a flicking of the wand would cause a spell to be cast. Upon its end, the wand would once again become inactive, restarting the whole loop again. In terms of implementation, the system went through two different iterations. The first idea for the system failed, but here is a digest of what was done and why it failed. In my first idea, the controller holding the wand would record its position in 3D space every instant, and I could then try and project that point from 3D into a 2D plane. Once in 2D space, it would be easier to try and identify what the gesture was, whether it was a circular motion, for example. I could use line intersections to identify whether it was a closed motion, and I could see whether its internal angles respected certain rules to see if it was a full circle. I would also require a minimum amount of points to make sure it wouldn't be a simple shape like a triangle. The problem with this idea was which plane I should use to project the points, and it was a misunderstanding over how a VR avatar works versus something like a computer screen game. The first plane I used was the player. I tried and project the points into the plane that the player occupied. The player seemed like a fit projection plane as it was independent from the camera or the hand actions. Unfortunately, this meant that while motions in front of the player worked fine, doing them sideways would not work, so this was a rejected possibility. Next, I tried the wand plane. Here I saw that trying to map points to the wand plane would give me a central point or an infinitesimal line that was not useful for any purposes. Finally, I applied the system to the camera plane. Here the problem was very similar to the body. Motions in front of the camera worked fine, but anything sideways would result in skewed motions. Reluctantly, I scrapped my personal implementation of detecting gestures and searched for a plugin that could do something similar, as it would be unlikely that no one had yet solved this problem. I found it in Real Store, the Gesture Tracker VR, for a cheap price and decided to use it. The system works by allowing us to first feed a gesture bank with gestures that we will want to track in the future. Then, during play, we ask it to find a match for the motions we are performing. The system allows for much more versatility, and even multiple bank gestures, so I created a system that could alternate between two different banks, one for activation of the wand, and another for the casting of the spell. Let's look how the recording was implemented. pickup wand will be activated and deactivated with gestures. It has an internal state machine for which gestures are being recognized. And like before, BP Motion Controller manages the gesture banks. The state machine looks something like this. The wand starts inactive and does not detect anything until it is picked up. Then, it waits for a circular motion before becoming active. It then waits for a flick to cast a spell. Once the spell is cast, it goes back to detecting a circular motion. At any time, if the wand is let go, it will stop detecting and go back to being inactive. Code-wise, the flow starts when the wand is picked up. It calls deactivate, which stops all particles and changes its state. And then it calls start sampling, which first stops all sampling of gestures, and then calls detect gesture with the enumerate wait for activation. Internally, it checks that it has a valid spell selected, and loads the correct gesture bank in the motion controller, in this case, wait for activation bank, and then begins gesture recognition. Anytime a gesture is recognized, an event is called on the BP motion controller. Here, it checks whether it has an attached wand and informs that wand the recognized gesture to its internal state machine. If it was waiting for a motion and that motion is detected, it moves on to the next step. In our example, it was waiting for a circular motion. Once a circular motion is detected, it activates the wand and starts detecting a flick. When the flick is detected, it casts a spell and goes back to detecting a circular motion. At any time, dropping the wand will cause it to stop sampling for gestures, hence inactivating the sampling. Although the implementation worked solidly, some design work was left undone before the school closed. This included recording left-handed gestures with left-handed people, making sure gestures were play-tested with multiple individuals instead of just my teammates, especially because the current flick bank does not work very well. And since this was my first time programming in Unreal, a lot of mistakes were made code-wise, and some refactoring is necessary to clean it up, such as moving variables from recording into the global space.
Moving on to choosing spells. Since our experience has several spells, we needed a way to select which one the user would be using. Ideally, we would have something that would be an inherent part of the VR experience, such as different wands where each would cast a different spell, or using our new gesture system, different gestures for each spell. Due to the requirements of having work for every teammate and the limitation that one of our designer peers only had UI, UX experience, we settled on doing a menu that would be summoned by the hand, not holding the wand. In terms of entities, the pawn was slightly changed to check conditions for showing the menu. The BP motion controller's orientation is used to trigger the showing of the menu and instantiates a world menu instance that renders and controls that menu, as it is designed in the spell wheel. Spell wheel is simply a placeholder I made, since the actual menu would have been created by my peers. A game mode VR game instance was created to store global information. And finally, the pickup pawn was changed so it could alternate between spells. Let's take a look at blueprints. Our flow begins with every frame of each controller, where it first checks whether conditions to hide the menu have been met. This includes checking whether a wand is attached, and a new function that checks whether a certain angle threshold has been achieved to show that menu. After potentially hiding the menu, it then checks for conditions for showing it. Does it have the angle? Does it not have a wand? If so, it then asks the pawn to show the menu. In the pawn, we need to guarantee that the menu was only shown when the opposite hand is holding the wand. So two simple functions were added. Show menu that calls check and show menu on each controller. A function that ensures that if the wand is in one hand, it will show the menu on the opposite hand with the correct scaling. We will then return to BP motion pawn, where the show menu function is called. It checks the VR game instance on whether a menu already exists. If so, it shows that one. Otherwise, it instantiates a new instance of world menu and attaches it to the controller in the menu offset position, which we can see in the scene view. Looking at the world menu class, it possesses a widget instance of the spell wheel. Some functions were created to animate the scale up and scale down from the hand, so it doesn't simply pop in when called, but instead gives the impression of being summoned from that hand. To do this, whenever appear or disappear events are called, a timeline that controls the speed of the animation runs. Every tick, it interpolates between current and final positions and scales, being able to be interrupted midway throughout the animation. Spell wheel currently only has 4 buttons, one for each spell. When hovered or clicked, they call a function called selectSpell. This function goes to VR Game Instance, compares the enumerate against a list of unlocked spells, and if they are already accessible, deactivates the wand and changes the selected spell. When casting, the wand simply asks the VR Game Instance for what the current selected spell is, and then casts it, if available. Since this was the last thing I was working on before the school closed, and I have no access to VR equipment, some things were left unfinished. First, although functions were created to change the color of buttons, these are supposed to change when hovering to show that the spell was selected. However, right now, once they are not being hovered, they will go back to a grayed out position. Secondly, the unlocked spell system would have been used as the player moved between each table, learning new spells. Currently, it has all spells unlocked and is ready to be used with unlocked spell functions. They simply need to be integrated with the progression of the experience. Finally, the menu itself needs to be replaced with the final UI, and everything would need to be playtested to make sure it has a good experience. As it stands, it is currently functional. The player can summon the menu and use it to swap between spells, and some bug fixing has been done to stabilize the system. Moving on to the main door. Of all the features we decided to have, one of them that was a nice to have was a main door that the player could use the handles to knock before entering. Since this was not essential work, and the exporting of the handles was going to require even extra work from our artists, we left this for later. For now, I simply created the animation for opening the door. In terms of entities, there is simply the door actor and associated meshes and materials that I integrated. Code-wise, it uses a simple timeline to interpolate non-linearly between 0 and 1. It then multiplies the result of that timeline by its final rotation. This was done by designers instead of animators, due to being simple and having more design resources, leaving our animator to focus on rigging and animating more complex models. Regarding the handle, I would have implemented a detection area. Once the handle left that detection area, it would be primed so that once the handle returned, it would trigger a sound and the opening of the door could start. For now, to allow access to the room, the door simply opens upon start. Next, my work as a team producer. The project started as a team effort between 4 designers, 4 3D modelers, 1 animator, and 1 VFX artist. I was chosen to take the role of producer to ensure that work would flow smoothly. From day one, I created a Discord channel so that we could communicate and create a workflow for the team. Following the recommendation of our teachers, tasks were created, refined, and giving Moscow priorities. Dependencies between each task was examined so that we could prioritize work, and each individual was given freedom on what they wanted to do. Unfortunately, at the beginning, the team was not very functional. Delays with starting the project, language barriers, and communicative individuals that disappeared, members that could only be present once a week for the laboratory lesson, and 2 new joiners who were completely new to their respective fields. All of these problems forced me to become a more hands-on producer. I created a new weekly sprint and allocated everyone with the work that they intended to do. Midweek, I would ping them for the progress reports, find out whether there was anything blocking them, and help out however I could. At the end of each sprint, during the lab lessons, I would go through what was done, nudge the team to communicate between themselves where connected work existed, and together with each individual, plan their goals for the next sprint. By the end of the semester, a noticeable difference existed in most of the teammates, and it felt to me like we would be able to compensate the slow start and deliver an interesting experience. In conclusion, the Wizardry VR experience was a project that required a lot of dedication and self-learning, as tasks required not only knowledge in design and coding, but also empathy and patience to learn from other fields, in my case, VFX, 3D modeling, and animation. With the closing of the VR lab, all progress in the project halted, and I have since been distanced from any sort of VR equipment to work with. This video attempted to document all the work I finished prior to that date, as well as my intentions for going forward. All shown imagery, with the exception of the slides, is the result of occasional recordings I made at the laboratory. Despite all this, I firmly believe that by working hard early on, I was able to finish up enough good quality work to show where our project was heading. Most of the interaction implementations are final, and would only need tweaks and the integration of assets that were being made. From a task perspective, little was left on my end, and I was working on nice-to-haves and helping the team with integrating their work. This video